All right. Thanks everyone for coming to today's lecture and Space Syntax Lab seminar on spatial design networks analysis from productivity to mega project evaluation and design perspective. We are very excited to welcome Professor Alain Chiaradia, who will discuss the integration of walking mode in large-scale urban design and transport evaluation frameworks. Alain is Deputy Head of the Department of Urban Planning and Design and Associate Professor at the University of Hong Kong, Faculty of Architecture. He's also the Program Director of the Master of Science in Urban Design and Transport. His research interests focused largely on understanding and design of high-density integrated transport interchange hubs. This includes transport-oriented volumetric urban design, as well as large-scale transformative mega infrastructure projects. He was also the lead co-inventor of the 3D SDNA tool for spatial design network analysis, which many of you will be familiar with. And before I hand over to Alain, I'd like to ask you to put any question that you have during the chat, during the talk in the chat, so we can address them after the talk. And in addition, we have introduced a new role of a discussant to our seminar, who will be in charge of leading the Q&A and who will also ask questions themselves. And I'm happy to introduce Merve Okali Savada, who is current PhD at our lab and who will take over this role for today. And with this being said, Alain, the floor is yours.
Thank you, Kimon, for the introduction. Good morning or good afternoon and good evening to everyone. I don't know where you're located. So I'm very pleased to kind of present this work. This work, I would say, is a work I was explaining, which I've done with two other co-authors, which are now in China, and both are some professor in the Beijing and Tongji at Tongji University in Shanghai. So this is the Ling Yan and Zhu. So that's our two paper. I probably will send it to Kimon and it can kind of like maybe distribute to the attendees. So the kind of like goal is to look at in a sense. I mean, I'm going to kind of move. So the big overview is like in a way is like a configuration spatial configuration analysis be used in very large kind of scale project evaluation in a way. So there's quite a good understanding about, I mean, space syntax limited in a way, where I've been a consultant and director for a while. I've been using a network analysis space syntax for evaluating master plan of different size. In this case, I mean, we have something else, which is like introducing a different mode. And I haven't seen anything that kind of introduce both, like we say, road and urban rail and kind of pedestrian. So the big question is like, can we work at macro, meso, and micro scale in a way? And in that sense, can we deal with a mega project? And this is quite a mega project I'm going to talk about. You include a road, urban rail, a new CBD, a new town, which is about for between 400 and 700,000 people. And Hong Kong has kind of like a different kind of like data. In particular, it's got a 3D pedestrian network. And the question as well is like, can we use explainable AI to kind of like predict, because AI is pretty good at predicting. Explainable, that's a different question, and then we will see how that process might be meaningful as well. So that's an overview. Now I'm going to give you a little bit of background and I will go fast and slow sometime because I have a lot of slides and then they will stay in a kind of like in a recording, but I'm not necessarily kind of like going to speak too much about it. So give you a little bit of context where I am. So this is a Great Bay Area, between 65 and 86 million inhabitants. In a way, I mean, that kind of like, that's, maybe at the pointer, that little kind of like ellipse here is 300 kilometer. Yes, 300 kilometer. And I think the M25 is about 200 kilometer circumference. So you can give you a sense a little bit about the density of people that is living quite in close proximity. So this is a little bit bigger than the M25, but there is about between 65 and 86 million around it. So that gives you, and then you have 4 core cities around it. Okay, so this is for airport, and this is a network of MTR network that link, in fact, and then as well there's a high-speed rail that link as a 3 city together on the kind of East Coast, in a way, on the east side. Then, I mean, just to give you a sense of like what I mean by design perspective, when in the title, is to look at how those big mega cities are organized in a way. And in kind of configuration aspect of network analysis, we do look at kind of like the connectivity and kind of like the shape of the network and different scale. What is less kind of taken into account probably is like time, like how the time warp space in a way. Like if you have like in the same kind of like model, you have walking, you have like driving, and you have like a urban rail network. I mean, and that's kind of like the interplay between those 3 things change as well the kind of modeling. And that's an interesting aspect as well. Okay, this is zooming onto Shenzhen and Hong Kong. Give you a little bit more kind of like, so you can see that the very dense metro network in Shenzhen north side, which is Fujian, Wu, and so on, which is kind of like going from east to west, and Hong Kong, which is more kind of like on the south side and very long line in a way. So to give you a little bit of sense of what kind of city Hong Kong is, I mean, it's an interesting question. If you ask people, I mean, is Hong Kong compact? Everybody will say, yes, it is compact. And then if you look at the shape of the kind of built shape, is anything but compact in a way, because I mean, it's more like a series of corridors. And that's the intriguing part in a way. By this series of corridors, it's quite efficient despite the dispersed urban form in a way. Very dense, everybody knows that. Maybe less known is like everybody is almost like 5 minutes away from a mode of transport. And then when they have used that mode of transport, they have 5 minutes away from where they want to go as well. So this is quite an interesting thing. And is a public transport city. 90% of people use public transport every day. There's only 10% of people having 10% of household having a car, and is rising, but I mean, it's still, I mean, very far from everything. So there's a bit of strategic planning. Recently, I mean, we have like 2 kind of like area, like the Shenzhen area, which is like the northern metropolis, with the south of Shenzhen and the north of Hong Kong, and the harbor metropolis, in a way that give you an idea of what is kind of like happening. And there's a lot of kind of like project to increase the population, and I'm not going to kind of like so essentially, I mean, the north is going to increase from 1.5 million to 2 million, and from the other one is like from 3.5 million to 4 million. The question is like the south side have 70% of the job, and the question is like how the job are going to move in a way or not. A lot of new town. I mean, that's kind of like no new town in the harbor metropolis, 4 new town in the north metropolis, and then you have like in between or a little bit outside the harbor metropolis new town with different kind of aspects. So this gives you a little bit of background. So question is like multimodal configuration analysis can explain HK-wide accessibility, and in turn explain job productivity and the relative location of job and residential population. Well, the answer is yes, because we published 2 papers that have been accepted. And so how did we do that? And why is it interesting for a design perspective with configuration? A bit of history. So the project I'm going to talk is Land Out Tomorrow. So they were initially in 1990s, they were the idea of moving the harbor, which is over there, to move it over here. And then this changed in 2016, it became something different. It became a new town, and with 200,000 employment opportunity, a new town for 400 to 700,000 people, a new CBD, and so on. And this has kind of evolved and continued to evolve. And so can we, validate with configuration analysis a social scenario? I'm not saying we're predicting, but can we give some sense of like validation of some scenarios that are at that scale and early stage? And you can see there's very little information. There's location, job, population, and population quantum. So infrastructure in terms of network, and that's very good for configuration network analysis. And that's about it. Nothing else. So how can we validate with so little? Okay. Okay, so let's look at this. So we use transport infrastructure investment as, we know that, transport infrastructure investment is used as a policy for stimulus, as known. There's a traditional evaluation of transport investment, CBA, cost-benefit analysis. And, there's got a lot of problem, and, there's been a lot of criticism about it. And notably that it failed to incorporate what is called wider economic impact of transport, which can be positive or negative and so on. And so that may lead to kind of like some transport options that may not be the best in a way. So a sample diagram, CBA, so you look at the value of time and how you kind of improve time travel, and that's a direct user benefit. While wider economic impact, if you look at more than that, because that's change in proximity has an impact on agglomeration, and agglomeration has an impact on productivity, wage, total factor productivity, and the gross value added. It has an impact on labor market, and so on. So there's a lot of things. So this is a simple diagram. I'm going to pass quite quickly on the following page. It is more elaborate, but you will see that, for example, we know that change in transport accessibility can change the price, but more importantly, can change productivity agglomeration, but as well have impact on social cohesion, impact on air quality, can have an impact on public health, and so on. So there's quite a lot of work on this. So if we bring all this thing in relationship to transport, then we have quite a complex kind of like relationship between built environment, urban design, and transport. And that's we know that, but the question is how to address. So can we estimate the kind of like causal effect of transport network centrality, accessibility on job productivity? Yes, we can. So we do a model, and then not surprisingly, the question, which transport infrastructure in Hong Kong are most invested in? So that's one part of the study. There is quite a lot of kind of like literature on this. So urban agglomeration and the micro foundation, sharing, matching, and learning are the three kind of micro kind of economic aspect of urban agglomeration. Sharing might be sharing a large, vast kind of like infrastructure, for example, or even a large stadium, or even an opera, which you cannot find in kind of small place. Wider economic of transport, we've seen different aspects of it. And so there's some issue because, there's sometimes what is called reverse causality. There's investment because, a place is doing very well. So there's kind of like difficulty sometimes kind of like working out causality. And then you may have as well, in your model, omitted variable. So there's a technique which is called the use of instrumental variable, or there's another one which is kind of like quasi-experiment. We use an instrumental variable approach. So most of the literature focus on road and rail, and I would say that in most of the time, walking is excluded. We didn't put cycling because cycling in Hong Kong is happening in the new territory, but is not happening in the most of Hong Kong. Yeah, so this is kind of related literature. This a simple point that in a service and knowledge and economy, the need of face-to-face interaction and leading to knowledge and spillover is quite well, I would say, start to be relatively well kind of like mapped in the literature, but it's not very well kind of integrate in an empirical analysis. And that's what we try to do with having a pedestrian network into the model. So this is a translog function. On one side, we have gross value added. On the other side, we have distance to, on the right side, we have distance to central from a road network perspective. And then we have a different network centrality. We use SDNA. We use SDNA for one reason as well, is it's got a hybrid metric which combine angular analysis and what we call Euclidean analysis along network. So we have both together in the same metric. And we use betweenness and then farness and distance to the nearest station for those network. And then we have some kind of control. So this is a little bit some kind of like mapping. So this is a financial job density. You can see that Hong Kong is essentially a monocentric city, and the new town are mainly kind of dormitory, one could say. Yeah. So we have data from 200 zone. We have MTR road and pedestrian network from the land department, and we have kind of like different kind of control and so on. Now the result. So the result essentially, I mean, yes, I mean the distance to central is very important. That's not difficult to see from the result, and this in the metric that is important in most of econometric model. What is a surprise here is that the pedestrian kind of accessibility at kind of like a walking scale is, I think, in all the study we use various kind of like a radius, and then we had one which our preferred one which come from a travel survey, and so by looking at the the multiple radius, we could see if the travel survey average kind of travel time or walking time were relevant. And in each case, in a way, the travel survey was a radius that was the most relevant. So that kind of like give us kind of some indication about using travel survey to define a radius is a good aspect of. So productivity is indeed kind of like related to kind of like spatial accessibility. And in particular in Hong Kong, no surprising, very much related to MTR. The road network, I mean, it might be looking a bit strange because, I mean, 40%, 50% of people use bus. And so there's quite, one would expect that the road is important. But we think that, I mean, this is captured mainly by distance to central, which is through the road network. And given that the monocentric quality of Hong Kong, there's a lot of bus that are kind of like express bus coming from different parts of the new territory to central and very direct as well. So although, I mean, on one side, road is not significant most of the time, it is important and captured by the distance to central. Now, I mean, the two second line are quite interesting because what we did a typical, in the third line, the third model, we omitted the pedestrian network. We just kind of like, okay, what happened? And what was interesting, and this situation is mostly in every kind of transport modeling, pedestrians are not included. So what is interesting, then road become more important. So when you omit a variable, so you have this kind of like road that become important. So this might kind of like explain why when so much of investment is directed to road and not necessarily to pedestrian. Then we did in our last kind of line and model, we did another experiment where we look at, well, I mean, it's not always possible to have a pedestrian model that is given by your authority as open data. So whether we could use the road network as a proxy for the ped network and analyze in the same way. So we can see that, in fact, I mean, there's a little bit of, it is feasible, but there's a little strange kind of relationship in terms of distance to central, and as well, kind of like pedestrian will become very, very important in some area, which are probably related to the core area, which are more street-based versus the kind of like the new territories that are much less street-based and where the pedestrian network is segregated from the kind of road network. So yes, productivity, we can use configuration analysis. We could look at the large scale. It would be great to do that for other city. So if anyone is interested, I'm happy to kind of like help. Okay, so this we look at sensitivity analysis by sector. There's different aspects as well, and I won't go into the detail. That can be read, I mean, easily through this. So essentially, and not surprisingly, I mean, one could kind of say, well, investment in working in Hong Kong is very important, and that's not surprising. But what is good is like we done it at a city level, and with a very robust causal kind of model, and with all the transport mode which are very important in Hong Kong. So in sense, we have a kind of configuration analysis that allow us to kind of like be a little bit confident to work at a very large scale. So, okay, I pass on this, and then okay, let's look at the second study, which this time look again at the job location in relationship to residential location. And before we go into scenario. So essentially, I give you an overview. This is about, I mean, looking at imagining we want to do a mega project, and we have a scenario, we have a new town, a CBD, we have some idea about the alignment of the road and the rail. We have an idea about how much maybe people are, how many people are working there, or how many people are living there. Can we test that kind of like, can we give a sense of validation to that kind of scenario? Or can we kind of like do several scenarios and kind of like see how it works? So that's the main idea. So there's not much, I mean, such a eccentric kind of appraisal for very sparse data, kind of like a specification of what the project is in a way, because I mean, it's very little in a way. So that's a kind of a rather beauty, I would say, of configuration analysis. You can kind of use a network analysis, and it's not very demanding, and you can use also kind of a proxy for making scenario, and that's what the idea. So that's what we did at the beginning. We use a kind of set of what is called a semi unrelated regression. It's like a semi a structural equation modeling, but slightly different, but I mean very similar as well. And then we have all the kind of like relationship between employment and population is interactive, and then we can look at how and which variable are kind of like the most important and so on. And so those models assume, I mean, in a way, a linear relationship between the variable and employment and population. And that's not maybe one of the kind of like, in a way, I mean, we see that it's not really linear. So an idea was kind of like to really test a scenario. Can we kind of use a neural network to kind of like really understand, I mean, and predict what would happen? And that's the first kind of like the third part of the project. And then we can compare. So that's kind of the idea. So so this is a vision, is a strategic vision. So it's kind of like different than kind of a predict and provide somehow. So this is kind of more like vision and validate, because I mean, when you have an accepted vision which align kind of and guide collective action, you may have like a self-fulfilling prophecy in any good vision, and they may work at the end of the day, even if they were kind of like a little bit rather kind of like at the beginning, I would say ambitious and optimistic. So can we kind of understand those aspects? So there's as well, most of the mega projects are fail to live up to their vision promise. And there's an optimist bias which has been integrated in most of the CBA in the UK. So, and in general, in a kind of vision and validate kind of like for a large scale project, it's more a conformance-based kind of evaluation, which say, did we follow all the right steps in a way? And then we kind of like, and sometimes there's a little bit of performance-based evaluation. And then as well, there's something we call reference class forecasting. And that's the technique we use in this case. So I'm going to go quite fast because then I want to go towards the end. So these are kind of the technique we use, the methodology. We use as well a classic model, which didn't work. This is not included in the paper, but this is quite interesting to show. We did a gravity model and we did a gravity interaction model which couldn't kind of like explain employment location. So I mean, it was an interesting exercise, but didn't kind of report it. We as well realized that there were kind of quite a lot of non-linearity in the model, in the classic model. And so we start to kind of like deal with a different type of model and use all the CPD and the Newtown as a kind of reference class, and then have all that with as well network accessibility and MTR network, as you've seen in the previous modeling, road network and the pedestrian network as well. So that'll give you a bit what it looked like, the distribution net, and so on. So I go quite fast, and then this is the result, and the results are pretty good, and so we can explain quite well the population and employment location, and that's kind of like what we wanted to do in a way. So this is a preliminary model with elasticity of population density and elasticity of employment density according to accessibility of those three networks. So that's what we aiming to have. So then we can use, in a way, we can use those elasticity in relationship to accessibility to predict or to validate as a better word. We're not predicting really, but we kind of like, let's say, test a little bit the proposal to understand, I mean, the realism of that proposal. Because essentially the proposal by the Innovision was essentially taking central jobs and saying, okay, that's CBD1, and then saying, okay, we're going to have the same amount of job in CBD3, which is a bit kind of like over optimist in my view. And everybody think of it, but it's kind of like one way is to say, yes, it's over optimist. Another way is to have a sort of tool that allow you to kind of say, yes, it is. And that's what we did. So we have control and so on. So the result, let's look at the result, because I mean, that's the idea. We use an explainer AI, so we feed in a way the variable that were significant of the SEM, and then we feed that into the explainer into AI, and then see what come out. So we feed some scenario. So we calculate. So that we calculate in a way the change in accessibility for MTR that go into the model, and then we take kind of proxy for road and the pedestrian as a scenario. We say, okay, what if we have the same kind of like type of level of accessibility for this new CBD that we have in Central or we have in Kuala, and we feed that in the model and see what happens. You know. And what happened is kind of like for the population in general is kind of like relatively kind of like okay. So we get about, I mean, as a bit kind of lower end of the scenario, but for the job is kind of far away in a way. So this kind of like give us an understanding that perhaps, I mean, the jobs are kind of overestimate quite a lot. And this may have kind of like quite an impact on the financial model of this project, because I mean, a CBD with 100,000 jobs is different than a CBD with 200,000 jobs in a way. And in that sense, I mean, that CBD3 is more like a CBD2 in a way than really like a CBD1. And we have no idea of any cities that have a CBD which is as big, secondary CBD which is as big as the CBD, the main CBD. So the model in a way doesn't kind of like validate somehow the scenario on the level of the population, and kind of like raise some doubt in a way. I mean, the doubts were there, but kind of like provide a little bit more fuel to the doubt about a question of employment. Now, so let's say we have a technique in a way where all the transport network are strong predictor of population and employment distribution. We have as well kind of like something that we knew and is somehow corroborated by this kind of scenario test, and that's this is kind of like maybe over optimist. we have as well something which is a kind of like really revealed preference of a market-led model, which is kind of like labor market usually follow accessibility. That's quite known as well in London and in Paris and many other cities. And we have a way of profiling that accessibility through the different network. So yeah, the kind of like new town is probably the most kind of like goal that is kind of like plausible, and is a matter of time and positioning. And so in a way, I mean, there's question, and everybody still have question about, I mean, the job kind of quantity for CPT3 and the implication on financial viability. So the future will tell, but it was a good exercise to do and to understand. Now, what I want to do is kind of return a little bit about the design perspective in a way. The interesting thing is that all the networks that we use are design sensitive, and that's quite intriguing and interesting. While in most of the transport network, the design of the network become implicit at one stage of the modeling, when in fact, I mean, everything is transformed into time or cost in a way. And we have an explainable AI, which kind of like meaning that, I mean, we know that the variable that we put in are significant. We kind of like select them, and then we fit them in ANN, and then kind of like, which have a more flexible functional form, and then kind of like provide a better elaboration in a way of scenario. So this is an important aspect. Having worked on different planning projects, it's very difficult to tell a planner, well, the model tell us, I mean, this is the case, without being able to explain how it would work. So explainable AI in planning and design is quite important. And I think Stephen Lowe is probably going to kind of like tell us more, I mean, in a few weeks time about explainable AI in a different way. Now, coming back to really what interests me is about the design perspective. So typically, I mean, what we have in a way, we have usually a grid. What I mean, which like we have a grid, a street grid, which is relatively well kind of like distributed and so on. And over it is overlay in a way a mass transit system, and they have a very different kind of like effect. Because I mean, in normal city like London, the distance between the kind of a train line and or the metro line, except in the center, are very, I mean, very sparse in a way. While in Hong Kong, I mean, we have very different kind of like situation. We have a corridor city where, in fact, I mean, we never far, except maybe on those 25% of Hong Kong, we are never very far from MTR line. And then, I mean, as well, because it's constrained, the urban fabric doesn't go very far. And so it's very different than a normal city where the two, there's kind of like a big gap, and the road is much more predominant. So that's one key aspect in a way to realize that kind of like large scale design difference. Now, what I mean, I'm going to kind of like elaborate how can this could be applied to London, and one could kind of wonder, is it possible to apply the thinking of Hong Kong to London? Think about it. In London, in fact, you have a lot of conservation area, or effectively you cannot build. You cannot build much. So in a way, there are those places where now they are like in between those kind of like line in a way. It could be the place where there's conservation area. It's not low density, but, and then you have those corridors that could be high density or very high density along the kind of like a metro line and so on. So one could kind of elaborate, and that's something that would be, could speculate on the design of London along the corridor, which are the transport corridor. And if one is aware of it, effectively, it is happening because you have what is called a public transport accessibility level policy, which kind of put together a public transport accessibility level and density in London. So somehow London has got an intriguing kind of like planning system with this public transport accessibility level that may end up kind of looking like a corridor, this kind of TOD, high density around metro station, train station, and so on. Another example which would be of interest in a way, it raises a question in a way of the monocentric aspect of Hong Kong in a way. We've seen that in one of the picture, you can see that effectively 70% of the job are essentially in the kind of core area, in a kind of like the north side of the island, central, Wan Chai, and kind of like Admiralty and Kowloon. And then the rest is kind of dispersed everywhere else. And this is happening in New York, this is happening in kind of like Paris, and so on and so forth in a way. And that's kind of creates sort of kind of like, I would say, transport inequity, because I mean, essentially the investments are always pointing toward the center and increasing accessibility all the time in the center by making line going through the center. And an example that has been kind of proposed in Paris is to do a sort of kind of like a different system where you have like two ellipse lines that in fact don't go through Paris, central Paris at all, but link all the new town together and all the suburb together into a system that is independent of of the center, which means that if you want to go in the periphery, well, if you want to go from here to here, in this case, you have to do this, or you have to do this. And in fact, what people do is kind of mainly driving between those two. And that's what is happening in most of city. The driving is happening mainly from suburb to suburb. So the idea of kind of Paris with the Grand Paris Express is to link all the suburbs and in fact to diminish. So we did a little test of model of this kind of like configuration. And what is happening is that kind of like displacing the, stop kind of like increasing the accessibility of the center, and then displacing accessibility, and then kind of distributing it around between the kind of like the branch, and then between the different new towns that are making the suburb of Paris and all. So this is an interesting tool that now we could kind of like, given that, I mean, the kind of like, I would say relatively good result that we've been kind of like making in Hong Kong. I mean, it could be interesting to use those tools, kind of like envision very different design, infrastructural design for different cities. So that's more or less the end of my talk. I think, yes. And then, I mean, just to give you, yeah, so that's to go back to that question of like travel time and the distortion of accessibility by urban rail, which is different than kind of like simply looking at the distribution of connectivity. And that's give you a sense a little bit about, I mean, what it looked like, the analysis looked like for people familiar with space syntax analysis. So this is, I mean, in the middle, we have the pedestrian network, and I think this is the 400-meter hybrid radius. Hybrid mean both Euclidean and angular along network. And the road network, which is in 2D, is similar. I think it's 8 kilometers, which corresponds to the most kind of like travel time in on road. And on the left-hand side is in fact the road network, but processed as with a 400-meter metric as a proxy for the pedestrian network. So if you don't have, and I mean, our model kind of show that, one of our models show if one doesn't have a pedestrian network, a dedicated pedestrian network, one can use a road network as a proxy. So let's give you an overview of what we've been doing.
Thanks so much, Alain. This was really exciting and a lot of content. So I hope people will ask a lot of questions. Let me stop the recording first.